Hi there, this is a step-by-step video for 6.02, the Pendulum Lab. In following this video, I would suggest that you have the template open and pause when necessary to complete the assignment as you watch this video. So first off, the purpose of this experiment is to look at what variables might affect the period of the pendulum. We'll use the simulation in this video, and the outside use of the simulation is not necessary. The procedure, though, begins with stating your hypothesis. You need to fill in these first three red blanks, and I'll show you what this looks like. So, if we look at maybe just one pendulum, the first question is asking, if I change the mass of this pendulum, maybe to something larger, how is that going to affect the time it takes to swing back and forth? The second is asking about amplitude. If I change the angle that I'm releasing the pendulum from, say perhaps from here to maybe instead over here, how will that affect the swing time, which we call the period? And lastly, if I change the length of the string, how will that affect the time it takes for the pendulum to swing back and forth? So think about those for a moment and pause the video if you need to. Once you're ready, fill these three red blanks in with what you feel may be appropriate. Again, with a hypothesis, it's okay to be wrong. It's just your initial educated guess as to what you think will happen. Next, we're going to test mass. So what we're going to do is pick two values for mass and see how that affects the period of the pendulum. So let's go ahead and look at that. I'm going to set up two pendulums. They're going to be the same length. So I'll put both of them at 1.5. And I'm going to change their masses. I'll have one be 2 kilograms and the other is 0.5 kilograms. What we'll do is release them from the same angle. So for a moment there, we're not going to see them, but we know their masses are different. And we're going to watch their swings. Notice that they stayed together. The time it took for the 2 kilogram mass was really the same as it was for the 0.5 kilogram mass. So we can draw a conclusion for that. Here you can fill in 0.5 to 2 kilograms and then state your observations, what happened here. Next, we're going to test amplitude. So let's go back over to the simulation. We're going to keep their masses the same this time. Lengths need to be the same, but we're going to change the angles. So maybe pendulum 1 will start from, let's make it 13 degrees, whereas pendulum 2 maybe will start at 26 degrees. We want to watch them return to their starting points. So watch the blue swing away and return, and watch the red swing away and return. And let's see what happens. They both returned to their spots, their initial release points at the same time. So we can draw a conclusion about that as well. You can insert the two values that we changed the amplitudes to and state what happened in that portion. Now we're going to test the length. And here's where we can fill in the table with various values for the length, which got cut off a little bit here, and the time that it's taking in seconds. So let's take a look at that. I'm going to remove one of the pendulums just to make this a little bit easier. And let's start at a very small length. So for 0.6, we're going to also include a photogate timer so it can help us time this. And let's release from 32 degrees. All right, so it's giving us this value here. For a 0.6 meter long pendulum, the value was 1.5843. That can be recorded. Go ahead and pause for a moment to record and then come back for the next trial. We're going to move this up to 0.8. We'll restart the photogate and I'm going to bring this pendulum back to 32 degrees. This time for point 8, we got 1.8296. Go ahead and record, and we'll move on to the next. For 1 meter, the value is 2.0455, and we'll do just a couple more. Bring this back to 32. And for 1.2, 2.2408. Oops, let me try that again, and then we'll do one more. Bring this over to 32. And for 1.4, we get 2.4205. Go ahead and make sure you've recorded all of those in this section. And if there were too many, that's okay. At least fill in the table, and you'll be ready to complete a graph. Once you've made your graph, what I want you to be able to tell us is what kind of relationship is present. Is the data showing a linear relationship, hyperbolic, parabolic? Use your graph to help you describe this. Next up for question number 2, we're calculating L if t equals 1 second. So there you will need to go to your lesson and get the equation for the period of a pendulum and complete that calculation. Be sure to show all of your work and also look back at your graph to see if your calculation agrees. If it doesn't, that may be a good indication that you should call and ask for some help. Ideally, we do want to see those match up. And then lastly, for question number 4, do one more calculation, this time finding t with a given L, and again, refer back to your graph to see how that matches up. Finally, in your conclusion, you should be including 3 things. You want to restate your hypothesis and also indicate whether your data supported that hypothesis or not. Along with that, you should be stating your findings, also kind of rephrasing and re-mentioning the relationship that you discovered, kind of squeezing in whether you found the relationship to be linear, parabolic, or hyperbolic. And then lastly, any sources of error should be included. So we're looking for about 3 sentences. And if you do have any concerns with any part of this assignment, be sure to reach out to your teacher. Have a great day.